We're back for day 2 in lesson 310. It's Jean Adams from Flamingo Math. We're going to solve trig equations. Inequalities will be our third lesson. Today we're going to turn our focus on finding solutions to trig equations on one rotation around the unit circle. We're going to start with some factoring examples for single trig functions and then move to some multiple angle equations, a little bit harder. In example 5, we want to solve by the square root technique on 0 to 2 pi. So sine squared, we can isolate sine squared by adding 1 and dividing by 4. And then taking the square root of both sides. The square root of sine squared is sine, but the square root of 1/4 is going to be both the positive and negative square root of 1/4. So sine of x is going to be either positive 1/2 or negative 1/2, and around one rotation of the unit circle, those values will happen at pi over 6, 5 pi over 6, 7 pi over 6, and finally at 11 pi over 6. In example B, 3 tangent squared x minus 1 is 0. When tangent squared is 1/3, the square root of both sides is tangent of x, and the square root of 1/3 rationalized is going to be the square root of 3 over 3 to make that simpler to find. Again, that happens at the same angles as our a value, where x is pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6. Example 6, we want to solve on the same interval. This time we're going to factor, so I'm thinking of this pretty much like 2u squared minus u minus 1. You can think of that way, or you can think of it as the sign. So 2 sine x plus 1 times sine x minus 1 would distribute to give the original problem that we have. Solving the first factor, when is 2 sine x plus 1 equal to 0? That happens when sine of x is negative 1/2, and those angles are 7 pi over 6 and 11 pi over 6. And then solving the second factor, when is the sine of x minus 1 equal to 0? And sine of x is equal to 1 when x is pi over 2. So we had 3 angles that met those conditions. In part B, you can factor 3 cosine minus 2 times 2 cosine plus 1, and solving 3 cosine minus 2 equals 0. That works out when cosine is positive 2/3. So to find that with my calculator, I would find x using the inverse function, 2/3, and that would give me 2 different times, 0.841 or 5.442 radian. And the second factor, when is 2 cosine x plus 1 0? That would happen when cosine is negative 1/2. So in this case, x would be either 2 pi over 3 or 4 pi over 3. So we would have 4 different answers, 2 estimated answers and 2 exact answers, solving by factoring. For example 7, we want to solve the equation sine squared x times tangent x is equal to 2 tangent x. The best idea would be to collect like terms on one side. We can have sine squared x times tangent x minus 2 tangent x, and that leaves 0 on the right. Factor out a tangent as a greatest common factor. That leaves sine squared x minus 2. And then solving the two factors. When is the tangent of x equal to 0? Tangent is 0 at 0 and at pi. And then solving the next one, we have sine squared x minus 2 equals 0. That's going to happen when the sine of x is either plus or minus square root of 2. But if you go check square root of 2 with your calculator, you might recall that's bigger than 1. So this is a problem. That means that factor has no solution on this factor, since the square root of 2 is outside of our domain from 1 to negative 1. Square root of 2 is bigger than 1. So we can't have that. Plus or minus, plus or minus. Okay, as we continue solving more difficult equations, remember to use your graphing utility to check your solutions for these. If you graph the left side as y1 and the right side as y2, the solutions are the x-coordinates where the graphs intersect. So we want to consider these two. Here's some examples. You could try those on your own. I'm going to work example 8. The tangent of 2x is the square root of 3. So where is the tangent of 2x square root of 3? 2x is at pi over 3, because I've got my unit circle here, and tangent is the ratio of radical 3 over 2 divided by 1/2, which is square root of 3. That would also happen over here again. And we would want to know every pi k value. Dividing both sides by 2x is pi over 6 plus or minus pi over 2k. But we're going to evaluate, think about this. We've got a double angle, so our domain goes from 0 to 2 pi, and our angle is a double angle. So multiply everything by 2. 2 times 0 is 0. 2 times our angle is 2. 2 times 2 pi is 4 pi. So we want to think about this k value here, or n, whichever variable you're wanting to use. If k is 0, and we substitute into this general formula, our answer becomes pi over 6 when k is 0. When k is 1, and we substitute in here, we've got half of a pi plus pi over 6. So our next angle, double angle, will be at 2 pi over 3. When k is 2, we end up with 7 pi over 6. And when k is 3, we end up with 5 pi over 3. So I think we've met those conditions that we solved between 0 and 2 pi for that double angle, and found all of those cases that will hold true to our equation. Let's give the half angle in the next example a try. We want to solve from 0 to 2 pi. Our argument is x over 3, and we're looking for where the sine of a single angle is a half. So again, thinking about that domain, we've got our domain goes from 0 to 2 pi, and we want to divide or multiply by a third. So a third of 0 is still 0. A third of our angle is a third of the angle, and a third of 2 is 2 pi over 3. So we don't want to get anything bigger than that. Now, where does the angle equal a half? That would happen. Sine is a half. That's the y value. When we go up here to pi over 6, sine is a half. So we have a third of that angle is equal to pi over 6, and that's going to happen again every 2 pi radians. Multiplying both sides by 3, x is pi over 2, and 3 times 2 pi is 6 pi. So we want to do, oh wait, sine is also a half at positive a half at 5 pi over 6. So we want to look at those. Let's first do this one. If n is 0, we have pi over 2. If n is 1, we're way past 2 pi, because that's 6.5 pi. And then let's consider this angle at 5 pi over 6. So if x over 3 is positive a half at 5 pi over 6, and it goes every 2 pi n or 2 pi k, then multiplying by 3, x is 5 pi over 2 plus 6 pi. Well, that won't even work at all, will it? Because x can't be 5 pi over 2. That's already outside of our domain up here. So we really only have one solution. X is pi over 2 is our only solution there. And again, you can check that with your calculator and see that sine of a third x, if we sketch that, sine of 1/3 x, it's going to go really slow. And this value is pi over 2. But this value at 5 pi over 2, that's outside of the range 2 pi. 2 pi is 6.28, and we have 7.853. So this is not a valid solution, not in the domain. Those multiple angles or half angles or third angles, they can be tricky. So just be careful as you work through these. And we will look at the final portion that's all about trig inequalities in the last lesson for our third day here.